What is the ancient history of high-risk HPV types? Imagine viruses that have been quietly evolving alongside humans for hundreds of thousands of years. High-risk human papillomavirus types, especially HPV-16, HPV-18, and HPV-50, are prime examples of this ancient partnership. These viruses are DNA-based, meaning they have a stable genetic material that changes slowly over time. They primarily infect the epithelial tissues in the anogenital area and the head and neck regions. Some of these types are strongly linked to cancers like cervical cancer, as well as testicular and other reproductive cancers. Research shows that these high-risk HPV types did not suddenly appear in modern humans. Instead, they co-evolved with our ancestors and even with archaic humans like Neanderthals and Denisovans. Phylogenetic studies suggest that some HPV variants diverged nearly 500,000 years ago. For example, HPV-50 split into different lineages around 478,000 years ago, a period that overlaps with when modern humans and archaic hominins were interbreeding. This indicates that these viruses may have been transmitted between different human groups through ancient interbreeding, contributing to the diversity we see today. As humans migrated across the globe, so did their viruses. Different HPV variants are linked to specific populations and regions. For instance, some HPV-16 and HPV-18 sublineages are unique to Japan, with divergence estimated between 25,000 and 98,000 years ago. This timeframe aligns with the migration of early humans into Japan during the Upper Paleolithic period. Similarly, HPV-16 has various lineages associated with Europe, Africa, Asia, and the Americas. Interestingly, some non-European lineages tend to carry a higher risk of leading to cancer, which helps explain differences in cancer rates around the world. HPV viruses evolve slowly compared to many other viruses, with mutation rates only slightly higher than those of humans. This slow pace is balanced by their ability to generate new viral particles rapidly and their adaptation to specific niches. These viruses have specialized to infect human epithelial tissues, especially the basal cells in the skin and mucosa. This niche adaptation is thought to be a key reason why certain high-risk types can cause persistent infections and, over time, lead to cellular changes that may develop into cancer. Understanding this deep evolutionary history is crucial for grasping why high-risk HPV types are so effective at causing cancer. Their genetic diversity and long-standing relationship with humans influence how they spread, how likely they are to cause disease, and how we can prevent them. It helps explain why some regions have higher HPV prevalence and cancer rates, and underscores the importance of screening and vaccination. Recognizing that these viruses have been part of human history for so long reminds us that prevention strategies are built on a complex, ancient relationship that continues today. Always consult healthcare professionals for personalized advice and stay informed through trusted health sources to protect yourself from HPV-related cancers.